This mini project explores pathfinding in a 2D treasure hunt game or an environment where the main character must navigate the grid filled with various different obstacles and various different opportunities, such as the hidden treasure it aims to find by the end of the game. To achieve this navigation in terms of AI algorithms, I implemented the A-star pathfinding algorithm, which uses a heuristic function in order to find the shortest path out of every single path possible to the end treasure. What we do here is basically move from one point to another and optimize or select the best path in order to move to that single position. The basic concept behind the A-star algorithm is the usage of the heuristic function as well as computing a path cost, and in order to continuously find the best path for reaching that position, we iterate over and over until we find the optimal solution. Next, we have actual implementation or pathfinding with the algorithm, which behind the scenes of the A-star algorithm, what actually goes on is that we use the Manhattan distance as a heuristic function, which allows us to find the most promising routes and skip on those that aren't as promising. In this, what we actually do on a lower level with respect to coding, we use certain data structures such as queues and priority queues, which you can see later on in our code. We can implement our queues in such a manner that it allows us to find the most optimal path. What we have to do is to make sure that all of this is carried out dynamically with respect to random input, and in order to make the character move in the entire grid, keeping in mind where the obstacles are, keeping in mind where the end position is, and not colliding into any of the obstacles and finding the perfect path to the end. As you can see right here, we have a lot of real life applications. We can use it in robotics, we can use it in kinematic movements, kinematic equations, and as well as pathfinding for various different domains such as drones and so on. Next up, we'll take a look at the actual way in which the code is handled behind this. We have the code right here where we import the recommended libraries, we import Pygame for visualization, we import Q priority queue from queue in order to handle every single position and every single cell. And then we create a few classes of our own. Right here, we use a decorator in order to initialize the cell class and to use comparison methods. Next up, we have the actual treasure hunt main class, which handles every single performance or every single operation that carries out with respect to the entire game. Obviously, you can see there is the method to create obstacles and place them and place the treasure, all of which are randomized with the help of the random library, so no two inputs are the same. And after all that, we draw the grid, place every single cell there and color them, and then the usage of the A-star algorithm in find path, where we compute the best path based on the given score. And lastly, all of this is run in the main part or the main function of the entire file. Right here, we check if the file is the actual main file, and then we initialize the game or the treasure hunt class, and then we use the run method to initialize every single thing, and we quit once the optimal path has been found and the destination has been reached. Right here, you can see its output as such. When we press click on that, we can right here we have the movement. We can select a single cell and we can find out what the optimal path to reaching that place is without colliding into any each and every single one of these obstacles. Right here you can see all of the different movements and paths it follows. Thank you.